Alright guys, so we've already talked about estimating square roots, and before that we talked about working with perfect squares. We're going to use some of this information that we know to now help us work with triangles. So we're going to talk about the Pythagorean Theorem. So Pythagorean Theorem is a theorem that was invented by a Greek mathematician named Pythagoras. And Pythagoras realized that if you take the square of two sides and add them together, you can get a third side. So we're going to learn how to use the Pythagorean Theorem and go through the steps. We're going to do a couple examples. So the first thing we need to know a couple things about Pythagorean Theorem. First of all, it has to be a right triangle. So we can see right here, okay, we have a triangle. We have this little square in the corner, which we know means that this is a right angle, a 90-degree angle. And it needs to be a 90-degree angle. We need to have a 90-degree angle. It has to be a right triangle to use the Pythagorean Theorem. Second thing we need to know is obviously we know in a triangle there's three sides, okay, but we need to name these sides. So the longest side, the side that's always opposite, okay, of our right angle, is called the hypotenuse. Hypotenuse. Okay, so that's one of our sides. The other two sides, for now, the ones that are adjacent, okay, to our right angle, are called legs. So we have two legs. Pythagoras found out that, or he discovered, that if we square the length of one leg and add it to the square of the other length, that will add up to be the square of the hypotenuse. So if we want to find out what the hypotenuse is, we could just take the square root. Now that might sound like a lot of gibberish, so we're going to give you an example. He named the legs to create a formula. So he called this leg A, this leg B, and you can switch them. It doesn't really matter which one's which. And this one is C. And the formula he came up with was A squared plus B squared equals C squared. Okay, so this formula right here is what you're going to use every time for Pythagorean Theorem. So let's take an example and look at it. So we'll say that this length is 3 centimeters. Units are always very important, guys. 3 centimeters, we'll say this is 4 centimeters. Okay? And we don't know what this one is. So we need to solve for, right now we're solving for the hypotenuse. So we know our formula is A squared plus B squared equals C squared. I'm going to erase the triangle and just put it up in the corner so we can have a little more room to work. So we have 3. I'm going to leave out my units for now just so we can see it. Okay? So we have 3 and 4. And we know that this was A, this is B, and this is our C. So we have this formula here, A squared plus B squared equals C squared. So if I fill in what we know that this is A, so A equals 3, so it's 3 squared plus what we know B is 4, so B squared is 4 squared equals C squared. Okay, so we know again through our practice with perfect squares that 3 squared is 9 plus 4 squared, which is 16, equals C squared. 9 plus 16 is 25, which equals C squared. Now, a common mistake, guys, that people do when they're learning the Pythagorean Theorem is they say, oh, okay, 25 equals C squared. The answer of this hypotenuse here has to be 25. No, that's the answer of C squared. Okay, we want C, right? So we already squared both of these lengths. So what's the opposite of squaring? We know the opposite of multiplication is division. We know the opposite of addition is subtraction. And we've learned in this unit that the opposite of squaring is square root. So we have to find the square root of both of these. So the square root of 25 equals square root of C squared. Square root of C squared is just C, okay, because anything squared, the square root of it is itself, right? The square root of 16 is 4. 4 squared is 16. Okay, so it's c, and the square root of 25 is 5. Okay, so our length right here for our hypotenuse would be 5. And this would be a correct answer on a test. C equals 5, 5 equals C. That's your answer. Now, this is called a Pythagorean triple because we end up with 3 numbers that are integers. Okay, well, they're natural numbers. They have no decimals in them. There will be problems, of course, where we have to estimate some square roots, and they are not Pythagorean triples. They will end up with some decimals in your answer. We're going to look at another one. Okay, this time I'm going to tell you that this side is 5 and this side is 12. Okay, so we're going to do the exact same steps. We know that our A is 5, so I put 5 squared plus B is, well, sorry, B is 12, so I'm going to put a 12 in for my B, so it's going to be 12 squared. It's an ugly looking 2. There we go. Equals C squared. 5 squared we know is 25. 12 squared we know is 144. Okay, you guys know these from practicing with our chart and our math games that we've been playing in class. So that's going to equal C squared. 25 plus 144, if I do it over here, 4 plus 5 is 9, 4 plus 2 is 6, and 1, 169. So 169 equals C squared. Again, guys, the answer is not 169. So we need to figure out what the square root of 169 is. Because the square root of 169 is going to equal C. So we know that 13 times 13, because this is another one that we've been working on in class. 3 times 3 is 9. 3 times 1 is 3. Put my 0 down because I'm done with my 3. Moving on to the 1. 1 times 3 is 3, and 1 times 1 is 1. Add it all up. 9 plus 0 is 9. 3 plus 3 is 6. And we have 1. So 13 times 13, or 13 squared, equals 169. That means the square root of 169 is 13. So 13C. Again, this is a Pythagorean triple because it does not have any decimals. So 5, 12, and 13 always work. Another cool little trick before we end the video is all of the multiples of Pythagorean triples work. What I mean by that is, if you take a Pythagorean triple, so we just use 2. We know that 3, 4, and 5 is a Pythagorean triple. And we also know that 5, 12, and 13 is a Pythagorean triple, because we just did both of those. Now, there are other ones, but these are the 2 we're going to look at in this moment. When I say multiples, if I multiply all these by 2, well, 3 times 2 is 6. 4 times 2 is 8. And 5 times 2 is 10. This is also a Pythagorean triple because it keeps the ratio the same for the triangles. So if you multiply it by any constant number, you will get another Pythagorean triple. For instance, I could times all these by 3. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Okay? And there you go. You have another Pythagorean triple. This one would work as well. Okay? And you can kind of see a pattern here. I can just keep adding 3s because that's what multiplication is. This is 3 times 1, 3 times 2, 3 times 3. So it would just be 3 times 4. So I could do 12. We have 4, 8, 12. The next logical answer would be 16. And 5, 10, 15, 20. Which makes sense because 3 times 4 is 12. 4 times 4 is 16. 4 times 5 is 20. You can do the same thing over here. I'm not going to do as many over here, but just to show you that it works. If we double these, well, we know 5 times 2 is 10. We know that 12 times 2 is 24. And 13 times 2 is 26. This, again, is a Pythagorean triple. And I'll show you an example just to show you that it works. We'll take, let's do 9, 12, and 15. So here's my triangle. There's my right angle. Put 9, 12, and 15. Let's pretend we don't know what it is. We know it's going to be 15, but we'll pretend we don't know. So we have right up here in the corner, a squared plus b squared equals c squared. So 9 squared plus 12 squared equals c squared. 9 squared, 9 times 9 is 81, plus 12 squared, 12 times 12 is 144, equals c squared. Now, 81 plus 144, we can go over onto the side and do this. 4 plus 1 is 5. 4 plus 8 is 12. Put my 2 down and carry the 1. And 1 plus 1 is 2. So the answer is 225. Now, we know that 13 times 13, this is the highest one we worked out in class, is 13 times 13. That we've been practicing as well anyways. We know that's 169, so it's got to be bigger than that. So why don't we know that it's going to be 225 equals c squared. But if we want to do the square root of 225 and we don't want to use a calculator and we don't know, one of the ways of doing it is just guess and check. So we know it's not 13. Okay, because like I said, we know 13 is 169. So let's try 14 times 14. So see if 14 squared equals 225. 4 times 4 is 8. Oh, my goodness, no. 4 plus 4 is 8. 4 times 4 is 16. Brain fart. Put the 1 up. 4 times 1 is 4, plus 1 is 5. Okay. Now, we're done with our 4s. We put it on our 0. 1 times 4 is 4. 1 times 1 is 1. So 6, 5 plus 4 is 9, and 1. So 14 squared is 196, not 225. That's right. We'll try again. Let's try 15 squared. So 15 times 15. 5 times 5 is 25. Put my 5 down, carry my 2. 5 times 1 is 5, plus 2 is 7. Put down my 0 because I'm done with the 5. I'm on to the 1. I'm going to erase this so this doesn't confuse me. 1 times 5 is 5, and 1 times 1 is 1. Add them all up. 5. 7 plus 5 is 12. Put down my 2. Carry my 1. 1 plus 1 is 2. And there you go, 225, which is what we wanted. And so we know 15 times 15 is 225, or 15 squared is 225, which means the square root of 225 equals 15. So 15 equals C. There we go. So we have our Pythagorean triple of 9, 12, and 15.